Welcome everyone. In this video I'm going to go over a problem from 12.6, these quadric surfaces that's shown up on a previous exam. In this case we're in fall semester 2017, and I'm going to go over problem number 10 with you. Determine the quadric surface this equation represents. And so even if you happen to remember all of the different forms that these quadric surfaces can, take on, this one doesn't particularly look like any of them. And so we have to be a little bit clever here, right, of figuring out, okay, which quadric surface is this? And the way that we do that is by graphing these traces, right? So I'm going to go ahead and maybe set certain things equal to 0 and whatnot and kind of see what happens, kind of what traces we get. That should make up the surface. All right, so why don't we go ahead and start off with something, for instance, I'm going to choose x equals 0. That's kind of like a classic place to start. So if x is equal to 0, let's see which kind of graph we get from this. So if x is equal to 0, I'm going to have y squared plus z is equal to 0. That's going to give me z is equal to negative y squared. So z is equal to negative y squared. This is going to be a parabola. All right, so I know I have at least one parabola, right? And so kind of maybe already I'm kind of thinking, okay, not so much a hyperboloid of one sheet, maybe not so much a cone, not so much a hyperboloid of two sheets, right? Because these don't have any parabolas in them. So already I've kind of eliminated this down and I have an elliptical paraboloid or a hyperbolic paraboloid. All right, so let's go ahead and see maybe for my next one, if I chose y equals 0. So if y equals 0, I'm going to have z is equal to x squared. So z is equal to x squared, that's again another parabola. All right, so both of these actually have two parabolas in them, right? The elliptical paraboloid and the hyperbolic paraboloid. So, okay, maybe I don't still quite know yet. So let's go ahead and try another one. Let's try z equals 0. And at z equals 0, we get a little bit of nonsense here, right? So this may not be the best trace in order to choose here. So if I chose z equals 0, I'm going to get y squared is equal to x squared. So in this case, if I was to go ahead and take the square root on both sides, I'd get y is equal to plus or minus x. So these are straight lines. So these straight lines, again, this is not the best trace to choose, z equals 0 here. Actually, if you really are good friends and you can remember what an elliptical paraboloid looks like, you actually can eliminate this now and say, okay, it can't be an elliptic paraboloid. You're not going to have these straight lines that go on forever. The only one that it could possibly be is the hyperbolic paraboloid. But this becomes even more evident if we choose one other value, right? So if we choose maybe z equals 1 or z equals negative 1 or really anything else. So I'm going to choose z equals 1. And I'm going to get y squared plus 1 is equal to x squared, right? So everywhere I see a z, I plug in a 1. And so if I go ahead and rearrange this, I get x squared minus y squared is equal to 1. So this right here is the equation of a hyperbola, right? So therefore, you now see you have hyperbolas and you have parabolas. And so our answer is hyperbolic paraboloid, right? We have hyperbolas and paraboloids. Again, their names really make up these things. But again, let's go ahead and maybe choose one other value, right? I said you can choose any other one if you chose like z equals negative 1, for instance. Z equals negative 1, right? In this case, we would have y squared minus 1 equals x squared. And what I would go ahead and do in this case, right, I'd have y squared minus x squared is equal to 1. Right, so I'd go ahead and move that negative 1 onto the other side, making it positive 1, and I'd bring the x squared over. And again, you would see that this is a hyperbola. So again, kind of no matter what, you're going to have hyperbolas kind of at all the places where you don't have z is equal to 0. So if you chose z equals 2 or z equals 100 or whatever, right, all of these are going to be equations of hyperbolas. All right, so again, our answer is C. That's it for this video, and that's it for Chapter 12. I'll see you guys in Chapter 13.